Who was Werner Heisenberg? Was it this man? No! Werner Heisenberg was one of the most important scientists to the construction of the modern-day atom. He was born on December 5th, 1901 in Wurzburg, Germany, and he died February 1st in 1976. His father was Dr. August Heisenberg, a professor of Greek language at the University of Munich, and he later married Annie Wecklein. His education. He went to Maximilian School in Munich until 1920. Then he went to University of Munich for physics. In 1923, he became an assistant to Max Born at the University of Göttingen. From 1924 to 1925, he worked with Niels Bohr at the University of Copenhagen. In 1926, he became a lecturer in theoretical physics at the same school. Then he was appointed a professor of theoretical physics at Leipzig, and in 1941 he was appointed professor of physics at the University of Berlin. Some interesting facts about Werner Heisenberg. During World War II, he was taken prisoner by the U.S. and sent to England. Then he returned later after the war. He played a key role in the Nazis' research on nuclear and high-energy physics, and he later died of cancer.
So how did Heisenberg contribute to the current model of the atom? Heisenberg's major contribution to the study of the atom was his uncertainty principle, developed in 1927. This principle stated that one cannot know both the location and velocity of a particle with high precision. To quote Heisenberg from his uncertainty paper, the more precisely the position is determined, the less precisely the momentum is known in this instant, and vice versa. This principle originated from Heisenberg's matrix form of quantum mechanics and Schrödinger's wave mechanics. Physicists were skeptical of Heisenberg's matrix mechanics because of how abstract it was and how weird the math was. Physicists preferred Schrödinger's wave mechanics over Heisenberg's. Louis de Broglie proposed not only light but matter can behave like a wave, and this got a lot of scientists thinking. After Schrödinger applied his wave mechanics to the electron orbitals, he published a proof that said matrix and wave mechanics gave the same results and argued that wave mechanics were superior to matrix mechanics. This greatly angered Heisenberg and the believers of matrix mechanics. Heisenberg and Niels Bohr debated over which interpretation was right and came up with the conclusion that none were satisfactory. Pascual, Jordan, and Paul Dirac came up with unified equations known as transformation theory. This was the basis of quantum mechanics today. All that was needed now was an interpretation of these equations to connect everyday events to the quantum world. Heisenberg came up with a problem to measure the physical variables in the equations. Analysis showed uncertainties would always appear when measuring both velocity and position, and this was not an experimental fault. Afterwards, he wrote a 14-page letter to Wolfgang Pauli in February 1927. This letter evolved into a published paper later, and he shared this with the rest of the world, and it eventually became known as the uncertainty principle. To show you an example of Heisenberg's uncertainty principle, we are going to show you a real-life demonstration of it. Imagine that you are blind and you hurl pandas at objects to help you measure the distance between yourself and that object. If you hurl a panda at a movable object like this, you will know the object's position when it hits this object, but afterwards you won't know its position because afterwards it will have moved. Likewise, you won't know the velocity of this object until the panda hits the movable object. I'm Michael Chin, reporting to you live from Munich, Germany. Today I'll be interviewing one of the most world-famous physicists who has made a major contribution to our current model of the atom, Werner Heisenberg.
Hello, Michael. Good to be here with you today.
Alright, so Werner, how has your uncertainty principle contributed to our current understanding of the model of the atom?
Well, Michael, by showing that one cannot know the speed and position of a particle, I've disproved my buddy Neil's planetary, obsolete model of the atom, and laid the groundwork for a new model of the atom with areas of probability.
So, Werner, do you think any part of your principle of uncertainty is incorrect?
No, Michael, none of it is incorrect.
Well, there you have it. Werner Heisenberg.
We hope you've enjoyed our presentation on one of the most influential scientists to the current day model of the atom, Werner Heisenberg. Through our presentation of his early life, his principle of uncertainty, and how that principle affects the current day model of the atom, we hope we've left you wondering more about the atom.
And we hope we've left you mystified about one of the biggest mysteries in the smallest of worlds.